Welcome to SKRS, your go-to channel for future tech and AI. I'm thrilled you're here, and if this is your first time watching, make sure to hit that subscribe button and turn on notifications so you never miss our latest AI content. Today, I'm taking you on a fascinating journey into the world of symbolic AI, one of the most foundational and powerful approaches to artificial intelligence. Have you ever wondered how computers can actually think and reason like humans? Not just crunch numbers or recognize patterns, but actually understand rules, apply logic, and make intelligent decisions based on knowledge. That's exactly what we're going to explore today. In this comprehensive interactive course from our Future Tech and AI playlist, we'll start from the very basics and build up to creating your own intelligent systems. Whether you're completely new to AI or looking to deepen your understanding, this course is designed to give you both the theoretical foundation and practical skills you need. By the end of this presentation, you'll understand what makes symbolic AI unique, how it shaped the entire field of artificial intelligence, and why it's more relevant today than ever before. Before we dive in, if you're excited about learning AI, go ahead and smash that like button right now. It really helps us create more content like this. So let's get started. What is symbolic AI? Let's start with the fundamental question: what exactly is symbolic AI? Think about how you learned to play chess as a child. Did someone show you millions of chess games and say, figure it out? Of course not. They taught you specific, explicit rules. Pawns move forward one square, knights move in an L shape, bishops move diagonally, and if your king is threatened, you must respond immediately. This is exactly how symbolic AI works. Instead of learning from massive amounts of data like modern machine learning, symbolic AI uses explicit rules and logical reasoning to make intelligent decisions. The key insight is that symbolic AI represents knowledge using symbols like words, concepts, and logical relationships, and then applies clearly defined rules to manipulate these symbols and reach intelligent conclusions. Let me give you two concrete examples. Example 1, if raining equals true, then carry umbrella equals true. Simple, clear, and completely transparent. Example 2, if temperature is less than 60 degrees Fahrenheit and wind is greater than 15 miles per hour, then wear jacket equals true. This is exactly the kind of logical, rule-based thinking that powers symbolic AI systems. Now here's your first hands-on exercise. Pause this video and create 3 more if-then rules for everyday tasks you do regularly. This will help you start thinking in the logical, rule-based way that symbolic AI systems operate. Real-world examples. Now you might be thinking, this sounds interesting, but does symbolic AI actually work in the real world? The answer is absolutely yes, and you interact with symbolic AI systems more often than you probably realize. Let me show you 3 powerful examples. First, meet MYCIN, a medical expert system created way back in the 1970s at Stanford University. This system could diagnose blood infections and recommend antibiotic treatments better than most doctors at the time. It used over 600 medical rules encoded by expert physicians, and the amazing thing was that it could explain its reasoning step by step, just like a human doctor would. Second, Google's knowledge graph. This is what makes Google search so intelligent. When you search for who directed Inception, Google doesn't just match keywords. It actually understands that Inception is a movie entity, directed is a relationship, and Christopher Nolan is a person entity. This semantic understanding powers billions of searches every single day. Third, modern legal technology. Law firms today use sophisticated rule-based systems to analyze contracts, check regulatory compliance, and research relevant case law. These systems apply complex legal rules to factual situations, just like human lawyers do, but they can process thousands of documents in minutes rather than hours. The key point here is that all of these systems succeed because they operate in domains where expert knowledge can be clearly defined and logical reasoning is essential. Corso and CPTS. To really understand how symbolic AI works, we need to explore 3 fundamental concepts that form the backbone of every symbolic system. First, knowledge representation. This is how symbolic AI stores information. Instead of storing raw data like numbers, images, or text files, symbolic systems store facts, rules, and relationships in a structured, logical format. Think of it like creating an incredibly detailed instruction manual for a complex machine. but in a format that computers can understand, process, and use for reasoning. Second, the reasoning engine. This is the brain of the system, the component that takes all that stored knowledge and applies logical rules to draw conclusions and make decisions. There are two main types of reasoning. Deductive reasoning works from general principles to specific conclusions. For example, all birds can fly, Tweety is a bird, therefore Tweety can fly. Inductive reasoning works in the opposite direction. It observes specific cases and forms general rules, like noticing that every swan you've seen is white, so you might conclude that all swans are white. Third, ontologies and semantic networks. These define the relationships between different concepts in a domain. An ontology is essentially a detailed map showing how different ideas, objects, and concepts relate to each other within a specific field of knowledge. What makes this powerful is that when these three components work together, you get a system that can reason about complex problems in a completely transparent way. You can always trace back through the logic to understand exactly why the system reached a particular conclusion. Code example. Now let's see this in action with some real Python code. Don't worry if you're not a programmer. I'm going to walk through this step by step and explain exactly what's happening. We're going to build a simple traffic light control system using PyNo, which is a Python library specifically designed for symbolic AI and rule-based systems. First, we import the PyNo library and create a fact class called traffic. Facts are how we represent information in our system. Next, we create our knowledge engine called traffic control. This is where all our rules live. Now here's the really cool part. We define rules using simple decorators. The first rule says if the traffic light is red, then stop. When this rule fires, it prints our stop message and tells us what action to take, apply brakes. The second rule says if the traffic light is green, then go. It outputs proceed with caution. The third rule handles yellow lights. If the light is yellow, prepare to stop. Action, reduce speed. Finally, we test our system by creating an engine instance, declaring that the light is red and running the system. What happens? The system automatically identifies that the red light rule applies and tells us to stop. The beautiful thing about symbolic AI is that this logic is completely transparent. We can see exactly which rule fired and why the system made its decision. This same logic powers self-driving car decision systems, smart city traffic management, and industrial automation controls. History timeline. To truly understand where symbolic AI fits in today's world, we need to take a fascinating journey through its history, and trust me, it's more dramatic than most Hollywood movies. Our story begins in the 1950s and 60s, what we call the golden era of symbolic AI. This was a time of incredible optimism and groundbreaking discoveries. In 1956, Alan Newell and Herbert Simon created the logic theorist, the very first program that could prove mathematical theorems automatically. The excitement in the research community was electric. Scientists genuinely believed they were just a few years away from creating human-level artificial intelligence using pure logic and symbolic reasoning. Then came the 1970s and 80s, the era of expert systems. This is when the promise started becoming reality. Companies invested millions of dollars in systems like MYCIN for medical diagnosis and DENDRAL for chemical analysis. These systems actually worked incredibly well in their specialized domains, often outperforming human experts. But then reality hit hard in the late 1980s and 1990s. These expert systems had some serious limitations. They were expensive to build and maintain, they couldn't learn from new information, and they failed completely when faced with problems outside their narrow area of expertise. This led to what we call the first AI winter. Funding dried up, public interest disappeared, and many people thought symbolic AI was dead. But here's the plot twist that makes this story so compelling. Symbolic AI wasn't dead at all, it was just waiting for the right moment to make its comeback. Today, we're seeing the rise of neurosymbolic AI, powerful systems that combine the pattern recognition capabilities of neural networks with the logical reasoning power of symbolic systems. The lesson: sometimes the most powerful technologies aren't abandoned, they just evolve and find new ways to be relevant. Symbolic AI vs machine learning. This is probably the question I get asked most often. How is symbolic AI different from the machine learning that everyone talks about today? This is a crucial distinction to understand, and the answer reveals why both approaches are valuable and why the future belongs to systems that combine them. Let me give you a perfect analogy. Imagine you're learning to drive a car. The machine learning approach would be like putting you in a driving simulator for thousands of hours, letting you crash millions of times virtually, and gradually learning from all those experiences what actions lead to good or bad outcomes. Eventually, you become an excellent driver, but you couldn't easily explain to someone else why you make specific decisions. You just know what feels right based on experience. The symbolic AI approach would be like learning explicit driving rules. When the traffic light is red, stop. When the speedometer shows you're at the speed limit, don't go faster. When it's raining, increase your following distance. You'd know exactly why you make each decision, and you could explain your reasoning to anyone who asks. Both approaches have unique and powerful strengths. Symbolic AI excels at tasks requiring logical reasoning, clear explanations, and situations where you have limited data but expert knowledge. It's completely transparent. You can always trace back through the logic to understand why it made a specific decision. Machine learning excels at pattern recognition, handling noisy or incomplete data, and learning from massive amounts of experience. It can discover subtle patterns that humans might never notice. But here's where it gets really exciting. The most successful AI systems today combine both approaches. IBM Watson uses machine learning to understand natural language questions, but then applies symbolic reasoning for logical deduction. AlphaGo uses neural networks for position evaluation, but also uses traditional game tree search algorithms. Google's search engine combines machine learning for language understanding with symbolic knowledge graphs for factual reasoning. The future isn't symbolic AI versus machine learning. It's symbolic AI and machine learning working together to create more powerful, more trustworthy, and more capable AI systems. APPLICATONS. Now let's explore where symbolic AI is making a real, measurable impact in today's world. You might be surprised at how many industries rely on symbolic reasoning right now, behind the scenes, powering critical decisions that affect millions of people. And hey, if you're finding this valuable so far, don't forget to hit that like button. It helps other learners discover this content. Legal technology is perhaps the most natural fit. Law is fundamentally about applying rules to situations, exactly what symbolic AI was designed for. Major law firms use sophisticated rule-based systems to analyze contracts for compliance issues, research relevant case precedents, and even predict case outcomes. These systems can review thousands of legal documents in the time it would take a human lawyer to read just a few. Medical diagnosis systems continue to evolve from those early expert systems like MYCIN. While modern medical AI uses machine learning for tasks like analyzing medical images, the diagnostic reasoning often still relies on symbolic rules that encode decades of medical expertise. When lives are at stake, doctors need to understand exactly why an AI system is making a recommendation. Financial services is another huge area. Banks and financial institutions use rule-based systems for fraud detection, processing thousands of transactions per second, and applying complex rules like if transaction amount exceeds normal spending pattern and occurs in an unusual geographic location and involves an unfamiliar merchant type, then flag for immediate review. Business process management. This might sound boring, but it's actually incredibly powerful. Companies use business rules engines to automate complex decision-making processes. Insurance companies automatically approve or reject claims, e-commerce sites calculate shipping costs and apply discount rules, and manufacturing companies manage complex supply chain decisions. And here's one that might surprise you: search and recommendation systems. Knowledge graphs power much of what we see in search results and product recommendations. When Netflix suggests a movie or Amazon recommends a product, they're often using symbolic representations of your preferences combined with relationship rules. What makes all these applications successful is that they operate in domains where expert knowledge exists, where rules can be clearly defined, and where explainability is crucial. These are exactly the situations where symbolic AI shines brightest. Mini project. Alright, now it's time to roll up our sleeves and build something real. We're going to create a simple but functional expert system, a basic symptom checker that can help identify possible health conditions based on symptoms. Now, before we dive into the code, let me be absolutely clear. This is purely for educational purposes to demonstrate how symbolic reasoning works. Never, ever use automated systems for actual medical decisions. Always consult qualified healthcare professionals for real health concerns. That said, this project will show you exactly how expert systems encode human knowledge and apply logical reasoning to reach conclusions. Here's how our system works. We start by importing PyNo and creating a symptom fact class to represent different symptoms as true or false values. Next, we create our symptom checker knowledge engine. Now comes the interesting part. We add rules that connect symptoms to possible conditions. Our first rule says if the patient has fever and cough, then suggest possible common flu. It also provides recommendations: rest, fluids, monitor temperature. Our second rule is more serious. If the patient has headache and fever and stiff neck, then alert, seek immediate medical attention. This combination could indicate something serious like meningitis. Our third rule says if sore throat and runny nose, then suggest possible common cold. Recommendations: rest, warm liquids. When we test our system by declaring that a patient has fever and cough, the system automatically applies the first rule and suggests flu as a possible condition. This is a simple example, but real medical expert systems use thousands of such rules, each one representing knowledge that medical experts have developed and refined over years of practice and research. Here's your challenge: try extending this system to handle more symptoms and conditions. Add rules for things like allergies, migraine, or food poisoning. Think carefully about how different symptom combinations might suggest different diagnoses. The beautiful thing about this approach is that you're encoding real human expertise directly into the system. Every rule represents knowledge that a medical professional would actually use in their diagnostic reasoning process. Future of Symbolic AI. So what does the future hold for Symbolic AI? Here's the exciting news. It's not just surviving in the age of deep learning and neural networks. It's absolutely thriving, and there are some compelling reasons why. First, we're seeing an enormous demand for explainable AI. As artificial intelligence becomes more prevalent in critical areas like healthcare, criminal justice, financial lending, and autonomous vehicles, we desperately need AI systems that can explain their decisions. A judge needs to understand why an AI system recommended a particular sentence. A doctor needs to know why an AI suggested a specific treatment. A loan officer needs to understand why an application was rejected. Pure machine learning models are often black boxes. Even their creators can't fully explain why they make specific choices. Symbolic AI, on the other hand, provides clear, auditable reasoning paths that can be understood, verified, and trusted. Second, neurosymbolic AI is rapidly becoming the gold standard for sophisticated AI applications. Companies like IBM, Google, Microsoft, and hundreds of startups are investing heavily in systems that combine neural networks' incredible pattern recognition abilities with symbolic reasoning's logical capabilities. These hybrid systems can learn from data like neural networks, but they can also apply logical rules and provide explanations like symbolic systems. Third, there are entire domains where symbolic reasoning is simply irreplaceable. Legal systems will always need rule-based reasoning because laws are literally written as rules. Safety-critical systems in aviation, automotive, and medical devices require transparent, verifiable logic that can be formally proven and certified. Scientific reasoning often involves hypothesis formation and logical deduction that symbolic AI handles naturally. The key insight is this: symbolic AI isn't competing with modern machine learning, it's evolving to complement it. The future belongs to intelligent systems that can both learn from experience and reason with logic, both recognize patterns and explain their decisions, both handle uncertainty and apply precise rules when needed. That's the future we're building toward, and understanding symbolic AI gives you a crucial foundation for that future. Final projects. Now for the exciting part, your final project. This is where you'll take everything you've learned and apply it to build something genuinely useful. I'm going to give you 3 different project options, each designed to challenge you in different ways and show you how symbolic reasoning applies to different domains. Option 1, Travel Recommendation System. Build an intelligent system that suggests destinations and activities based on user preferences, budget, season, and interests. For example, if budget is low and season is winter and interest is outdoor activities, then recommend local skiing or winter hiking spots. This project will teach you how to handle complex rule combinations and user preference modeling. Option 2, Simple Legal Reasoning System. Create a system that helps determine contract validity or compliance with basic legal rules. For example, if contract lacks required signatures and involves monetary exchange, then flag as potentially invalid. This project will give you experience with formal rule systems and logical validation. Option 3, Smart Home Automation. Design an intelligent rule-based system for home automation that makes decisions based on time of day, occupancy, weather conditions, and user preferences. For example, if time is evening and house is occupied and outside temperature is cold, then increase heating to comfort level and activate warm lighting. This project focuses on multi-sensor reasoning and real-world automation logic. Whichever project you choose, here's the process I want you to follow. First, identify the domain rules. What are the key logical relationships in your chosen area? Second, design your knowledge representation. What facts and rules do you need to encode to make intelligent decisions? Third, implement the reasoning engine. How will your system process information and reach conclusions? Fourth, test with realistic scenarios. Does your system behave logically and provide useful results? Finally, document your reasoning. Can you clearly explain why your system makes each decision? This isn't just about making something work. It's about really understanding how symbolic reasoning can solve complex, real-world problems. Take your time, be creative, and remember that the best learning happens when you're building something you're genuinely excited about. Quiz. Before we wrap up, let's do a quick knowledge check to see how well you've absorbed the key concepts. Don't worry, this isn't a high-stakes test, it's just a way to reinforce what you've learned. Here's the question: what makes symbolic AI fundamentally different from machine learning? Take a moment to think about this. We've covered several key differences throughout this presentation. Consider what you've learned about how each approach works, what their strengths are, and how they handle knowledge and reasoning. Option A, symbolic AI is newer and more advanced than machine learning. Option B, symbolic AI only works with numerical data. Option C, symbolic AI uses explicit rules and logical reasoning. Option D, symbolic AI requires more training data to work effectively. Think carefully about what we've discussed. Remember the chess learning analogy, the traffic light example, and how we talked about transparency versus black box decision-making. The correct answer is C, symbolic AI uses explicit rules and logical reasoning. This is exactly what we've been exploring throughout this entire course, from the chess analogy to the traffic light code to the medical expert systems. Symbolic AI is all about encoding human knowledge as explicit rules that can be understood, verified, and explained. If you chose a different answer, don't worry. Go back and review the sections on core concepts and the comparison with machine learning. The key insight is that symbolic AI's transparency and rule-based reasoning is what makes it so valuable for applications where we need to understand why decisions are being made. Key takeaways. Let's consolidate everything we've learned today into 4 essential takeaways that you can carry forward in your AI journey. First, logic plus rules equals intelligence. The fundamental insight of symbolic AI is that computers can exhibit intelligent behavior by manipulating symbols according to logical rules, just like humans do when we follow explicit reasoning processes. You don't need massive datasets or black box algorithms to create intelligent systems. Sometimes clear rules and logical reasoning are exactly what you need. Second, history teaches us about resilience and evolution. Symbolic AI's journey from the optimistic 1950s through the AI winter to today's renaissance shows us that powerful technologies don't just disappear. They evolve and find new ways to be relevant. Understanding this history helps us appreciate why symbolic AI is making such a strong comeback today. Third, hybrid approaches represent the future. The most successful AI systems today don't choose between symbolic reasoning and machine learning. They combine both approaches to get the best of both worlds. Pattern recognition from neural networks plus logical reasoning from symbolic systems equals more powerful, more trustworthy AI. Fourth, applications are everywhere and growing. From legal technology to medical diagnosis, from financial services to smart homes, symbolic AI is working behind the scenes in more places than most people realize. Anywhere you need transparency, explainability, and logical reasoning, symbolic AI has a crucial role to play. The most important thing to remember is this: start small, think logically, and always build systems that can explain their reasoning. Whether you're building the next generation of AI systems or just trying to understand how intelligent machines really work, symbolic AI gives you a foundation that will serve you well throughout your career. The principles you've learned today, knowledge representation, logical reasoning, and transparent decision-making, these aren't just academic concepts. They're practical tools that you can use to solve real problems and build systems that people can understand and trust. RSORCS. Your learning journey doesn't end here. Let me point you towards some excellent resources to continue deepening your understanding of symbolic AI and related technologies. For tools and libraries, start with Pino, which we used in our examples today. It's beginner-friendly and well-documented. As you advance, explore clips for more industrial-strength applications and SWI Prolog if you want to dive deep into logic programming. These tools will let you experiment and build increasingly sophisticated systems. For books, I highly recommend Artificial Intelligence, a Modern Approach by Russell and Norvig. It's considered the definitive textbook in AI and has excellent chapters on knowledge representation and logical reasoning. It bridges the gap between theoretical concepts and practical applications beautifully. For online courses, Stanford's AI course and MIT's OpenCourseWare both offer excellent content on symbolic reasoning and knowledge systems. These courses are taught by world-class researchers and will give you a deeper theoretical foundation to build on. For community and support, join the AI communities on Stack Overflow for technical questions and Reddit's R Machine Learning for discussions about current research and applications. The AI community is generally very welcoming to newcomers who are genuinely interested in learning. Remember, the goal isn't to become an expert overnight. Pick one or two resources that appeal to you and start exploring. Build small projects, ask questions, and gradually expand your knowledge. The most important thing is to start applying what you've learned. Even simple rule-based systems can solve real problems and give you valuable experience. The field of AI is vast and exciting, and symbolic AI gives you a solid foundation to understand not just how to use AI tools, but how to think about intelligence, reasoning, and problem-solving in systematic ways. Congratulations, you've just completed a comprehensive journey through the world of symbolic AI here on SKRS, and you should feel genuinely proud of what you've accomplished today. Think about what you've achieved. You now understand the fundamental principles of symbolic reasoning and how it differs from other AI approaches. You've learned about the fascinating history of AI and how symbolic AI has evolved from early expert systems to today's hybrid approaches. You've seen real-world applications across multiple industries and understand why symbolic reasoning is crucial for explainable AI. Most importantly, you've built your own expert system and have the knowledge to tackle more complex projects. You understand how to represent knowledge, apply logical rules, and create systems that can explain their reasoning, skills that are increasingly valuable in our AI-driven world. Now, if this course helped you understand symbolic AI and gave you valuable knowledge, I'd really appreciate it if you could give this video a thumbs up. It makes a huge difference and helps us reach more people who want to learn about AI. And if you haven't already, please subscribe to SKRS and hit that notification bell so you never miss our future tech and AI content. We've got so much more coming, from neural networks to machine learning to cutting-edge AI applications. Share this video with anyone you know who's interested in AI or technology. Education is better when we learn together, and your share could help someone start their AI journey. Also, make sure to check out our Future Tech and AI playlist. We've got tons of content covering everything from the basics to advanced topics, all designed to make complex technology accessible and exciting. But remember, this is really just the beginning of your AI journey. The principles you've learned today, logical reasoning, knowledge representation, and transparent decision-making, these are foundational skills that will serve you whether you're building the next generation of AI systems, working in industries that use AI, or simply trying to understand the intelligent systems that increasingly shape our world. The future of AI isn't about choosing between different approaches. It's about understanding how different techniques can work together to solve complex problems. Symbolic AI gives you a crucial piece of that puzzle. So what's next? Take on one of those final projects we discussed. Start building something that excites you. Join the AI community here in the comments. I read every single comment. The world needs people who understand not just how to use AI tools, but how to build AI systems that are transparent, trustworthy, and genuinely helpful. You now have the foundation to be one of those people. Thank you so much for watching this SKRS course. Remember, the best way to understand intelligence is to build it yourself, one logical rule at a time. Don't forget like, subscribe, and share. Now go out there and start building the future. I'll see you in the next video.